This is part 7 of the Module 8 lecture. We're going to go back to the problem we started with in this section, and we're going to test this hypothesis. So it says that a recent report claims that 80% of internet users have taken steps to remove or mask their digital footprints. So an internet security company wants to verify this claim, and so they survey 792 internet users. Of this, 681 say that they have taken steps to remove the digital footprints. So now we want to test this claim at a significance level of 0.05. So let's summarize the information that we're given in the problem. So the population proportion under the null hypothesis, pi sub 0, is 0.8. We call this a hypothesized value. So the sample size is 792. There are 681 successes. So the sample proportion is 681 divided by 792. And that gives you 0.85985. And the significance level we want to use is 0.05. All right, so from the statement, the claim is that 80% of the internet users have taken steps to remove or mask their digital footprints. So they're not saying more than or less than, and they're claiming that this is the proportion. So that gives you the null hypothesis equal to 0.8. And we want to test this hypothesis. So the alternative hypothesis is that is not 0.8. So this tells you it's a two-tailed test with a significance level of 0.05. All right, we're going to assume that this is a binomial experiment. So then we're going to multiply the sample size times the proportion under the null hypothesis, and that gives you 633.6. And then we multiply the sample size times the probability of success, and that gives you 158.4. Both of these quantities are bigger than 5. Then we're justified in approximating the sampling distribution of the proportion with a normal distribution. And because we're going to use a normal distribution, then the test statistic is the z statistic. And now the way we calculate this, we use the calculated sample proportion minus the population proportion under the null hypothesis, and then we calculate the standard error like this. So we carry out this calculation, and then we find that the z value is 4.2107. So remember, the z values are multiples of standard deviations. This is telling us that this estimate is about 4.2 standard deviations away from this estimate, from the hypothesized value, the population proportion of 0.8. All right, so let's then use the critical value to find the the rejection region. So this is a two-tailed test, so we divide alpha by 2, so that's 0.025. Then using this probability, we go into table 4 and look for the probability of 0.025, and we find that the z-value is minus 1.96. So this is the critical value on the lower side of the distribution. Now, using the symmetry of the normal distribution, then we know that the upper critical value is just the same value but positive, so 1.96. So the rejection region is to the left of minus 1.96 and to the right of 1.96. So if the calculated value of the test statistic falls in the rejection regions, and either one, we'll reject the null hypothesis. Now, in terms of the p-value approach, then the z-value of 4.2107 is larger than the largest z-value of 3.49 in table 4. So that implies that the probability that the random variable z being less than z observed is practically 1. And the probability to the right of that z-value of 4.2107 is practically 0. That's what this statement is telling us. And the figure here is accurate, showing the probability to the right of this 4.21 is practically 0. So since the z observed is positive, we're going to use the rule we established for calculating the p-value. That will be 2 times 1 minus the probability to the left of the z-observed value, because we determined that that's 0, practically 0. 2 times that, well, is 0. And if you want to find the exact p-value, it's actually 0.000025, practically 0. All right, so now we know that the critical value, or if we follow the critical value approach, then we see the calculated value of the test statistic, 4.2107, is larger than 1.96. That means it's in the rejection region. Therefore, we reject the null hypothesis. Now, the p-value is very, very small, near 0, and clearly smaller than 0.05. So we reject the null hypothesis. Now, we interpret this decision as that there is enough evidence to reject the claim that 80% of the internet users have taken steps to remove or mask their digital footprint at a significance level of 0.05. And the natural question, well, if it is not 80%, what is it? Well, we can use our knowledge of how to calculate a confidence interval. And so if we calculate the 95% confidence interval based on what we learned in the previous module, you can determine that that confidence interval goes from 83.4% to 88.2%. So the true proportion we think is between 83.4% and 88.2%, higher than this 80%. All right, so you can see that we can connect problems where we ask you to test a hypothesis and then ask you to calculate a confidence interval and explain both. All right, here's another interesting example. In a Pew Research article, reports that 65% of U.S. adults reported regularly wearing a mask or face covering when in stores or other businesses during the pandemic. So a researcher curious about this claim, he selected 437 adults and asked them if they regularly wear a mask or a face covering when in stores or other businesses. Of these 437, 304 said that they do. So now we want to determine if the proportion of adults in San Antonio wearing a mask or a face covering in stores or other businesses is larger than 65%. So let's, and we want to use a significance level of 0.015. All right, so let's see if here in San Antonio we're doing better than in the national average, or the national proportion, I should say. All right, so let's summarize the information. So the hypothesized value of the population proportion under the null hypothesis is 0.65. The sample size is 437. There are 304 successes. So if we divide these two quantities, we find that the sample proportion is 0.6957. And the significance level is 0.05. So in here, you see that this organization claims that the percentage of face mask is 0.65. And we want to determine if the proportion in San Antonio is bigger than 0.65. So the organization gives you the null hypothesis that the population proportion is 0.65. And the alternative hypothesis says that the proportion is bigger than 0.65. So this is a right-tail test with an alpha of 0.015. All right, so we're going to assume that this is a binomial experiment. So using the sample size and the proportion of success under the null hypothesis, we find that that product is 284.05, and the sample size times the probability of failure is 152.95. Both of these quantities are bigger than 5. Then we're justified in approximating the sampling distribution of the proportion with a normal distribution. Because we're going to use a normal distribution, then the test statistic is the z statistic. And again, this is just a calculated proportion, the calculated sample proportion, minus the hypothesized proportion under the null hypothesis, 0.65. And then we use that 0.65 and the sample size to calculate the standard error. So the value, the calculated value of the test statistic is 2.0029. All right, so let's find where the critical region is. So this is a right tail test with a alpha 0.015. So if we go into table 4 and we use the probability to the right of the value, remember the table 4 gives you probabilities to the left, so we need to use the probability to the left to find the critical value. So we do 1 minus 0.015, we find 0.985, and then using this probability, you find on table 4 that the critical z value is 2.17. So the rejection region is to the right of 2.17. So if the observed value of the test statistic is in that rejection region, of course, we're going to reject the null hypothesis. Now, if we decide to use the p-value approach, then we use the calculated value of the test statistic z observed. And then if you go into table 4, you find that the probability for z less than the z observed of 2 is 0.9772. But that's a probability to the left of the z observed. We want the probability to the right because that will be the p-value. So we do 1 minus 0.9772. So the p-value is 0.0228. And that makes sense because it's just the area to the right of the z observed. All right, good. So now we have the p-value and we know where the rejection region is. So using that, if we decide to use the critical value approach, then we find that the z observed is smaller than the critical value. That implies that the calculated value of the test statistic is in the non-rejection region, and therefore we do not reject the null hypothesis. Now, if we decide to use the p-value approach and we find the p-value is 0.0228, then we see that that is larger than the alpha of 0.015. So again, because the p-value is larger than alpha, we do not reject the null hypothesis. So we can say that, or rather this researcher would say that the claim cannot be rejected that the proportion of adults in San Antonio wearing a mask or face covering in stores or other businesses is larger than 0.65. So we cannot say that at a significance level of 0.05. So we can say that in San Antonio seems to match the national proportion of mask wearing. All right, so with this we complete 2 problems illustrating how you can test a proportion. All right, so we're done with, I'm sorry, I have an extra slide. I will remove it, but it's the same interpretation. All right, so we're done with Module 8. The assignment is split in 2 parts. The part for 9.1 and 9.3 will be due this week, and 9.4 will be due next week because we're supposed to be covering this module between this week and next week. Again, consult the calendar on Wiley Plus to see when these assignments are due. All right, so at this point, you should be able to elucidate the null and alternative hypothesis from the description of a problem. You should be able to determine the direction of the test, and from that identify the, rather using the alternative hypothesis, you should be able to determine the direction of the test. You should be able to explain what the type 1 error is and what the type 2 error is and what are the probabilities. You should be able to explain the role of the significance level in testing a hypothesis, as well as the meaning of the p-value and its use to test a hypothesis. And you should be able to follow the 5-step procedure to test a hypothesis for a population mean and a hypothesis test for a population proportion. Again, we're done with Module 8. And now between the Module 7 and Module 8, we have seen the 2 key ways of estimating a population parameter. So what comes next is extensions of these 2 methods. All right, I will stop here. And this is the end of the Module 8 lecture.